Okay, so this video is being developed so you can use it as one of the resources in the lesson to help you learn how to draw a Lewis diagram of the atom. So I'm going to start by sharing my screen. And it's not going to work. There we go. Okay, gotta make that big. All right, so this is one of the resources that's in your lesson. You can use it. It's also not, you don't have to download the PowerPoint. You can actually just use, I put these step-by-step instructions as just a kind of bunch of images in there as well. So you can do whatever works for you. All right, and you'll need a periodic table. I've included one in your resources, but this is just one that I put in the PowerPoint and the instructions. I simply found it by searching on the internet, and here it is. So whichever one you want to work for you is fine. All right, so step one, move myself up here a little bit. You have to find the chemical symbol for the element. So the chemical symbol for this one, in this case, carbon, is C. So we're going to go ahead and look at our periodic table. Which is right here. Okay, sorry about that. All right, so if we look at our periodic table, and we're looking for carbon, carbon is right there. I know that's the best circle you've ever seen. Yay. All right, so what do we do now? We go back to the thingy here. All right, so now that we know the chemical symbol C, the second step is to write that capital C on your paper. And notice I'm asking you to make it a little bit larger than you would normally write the C. So if this is your notebook paper right here, instead of just taking up one line, take a couple of lines of space. All right, let me get rid of this. And we're going to go ahead and follow the steps together. All right. So here's going to be my gorgeous C. All right, let's go back to the PowerPoint. And what do we do next? So now it's asking us to find the group number for the element. So if you remember from what we were learning, I think it was yesterday, you were supposed to be learning how to read the periodic table. At the top of each vertical column goes up and down, so here's a 1, is a group number. That group number tells you really important stuff. And the most important thing is right here. The group number tells you how many electrons are in the outermost energy level of the atom. So group 1 has 1, group 2 has 2, group 3 has 3, and so on. So you find the group number. So if I go over here to carbon, carbon is right there, and it is group number 14. So I'm going to go and kind of make a note of the fact that carbon is in group 14. All right. So now what do I do? Back to my steps. All right, so I'm remembering the octet rule. So the octet rule is that the max number of electrons you can have in the outermost energy level is 8. There's 2 exceptions to that rule, and that's hydrogen and helium. That is because hydrogen and helium only have 1 energy level, and if you remember, the first energy level only can have a max of 2. All the others have 8. So this rule doesn't really work for hydrogen and helium, but it does work for every other element. All right, step 5. What about elements in a group where the group number is larger than 8? So we found carbon, and carbon's group number is 14. And if that 14 is telling me how many electrons are in the outermost energy level, then that's breaking the octet rule. So it can't have 14, it can only have up to 8. So what do? Well, there's this rule, and it's a little bit confusing at first, but I want you to recall from elementary school when you learned about the tens and the ones. So if you have a 2-digit number, if you look at this 13 here, the 1 here is in the tens place and the 3 is in the ones place. And that's important because to do the outermost energy level electrons for the periodic table, you ignore the tens place and just use the ones. And what that means is if carbon is in group 14, since 4 is in the ones place, that means carbon has 4 electrons in its outermost energy level. If it was boron, which is here, number 5, it's in group 13. That means it has 3. Nitrogen has 5. Oxygen has 6. All right, so I'm going to go ahead and I'm going to write that here. Okay, so it has 4 electrons in its outermost energy level. So what's the next step? Draw your electrons as dots. Start above the chemical symbol and put a single dot for 1 electron. I can do that. I'm going to go ahead and go back to here. And let's use the circle thing because I don't think you want to watch me do horrible dots. So I'll put 1 dot right there. Boom. All right. What do I do now? Place your electrons as dots in a specific pattern. So here's the rule, guys. The first one goes at the top, just like we just did. But after that, it goes right, below, left. So it goes up, right, down, left, up, right, down, left. If you look at this other one down here, this fake element I made up, XZ, whatever that stands for, you've got the first dot here, the second dot here, third here, fourth here. If it had 8, I would keep going, but the 5th one goes again next to the first one. The 6th one goes below the second one, and just like that. It's a little confusing at first, but you will get used to it. We will all get through this. All right, so I have to put 4. So I've put 1. The second one goes to the right. Third one goes down. And the 4th one goes to the left. All right. What do I do now? So here's an example of aluminum and neon. So aluminum is in group 13, which means it has 3 electrons in its outermost energy level. So I drew them, 1, 2, 3. Now I have to determine whether it's reactive or non-reactive. And the way you find that is first you look for what's called an unpaired electron. It means an electron that's all alone. So if you look at electron number 1, it doesn't have a buddy. It's all alone. Electron number 2, nobody. Electron number 3, nobody. So I circled all 3. What that means is aluminum can form 3 bonds. That also means that aluminum is reactive. If you look at neon, neon has 8 because it's in group 18. Every electron has a buddy. Neon's kind of happy. It cannot form any bonds, and it's a non-reactive element. So that's how you know. So what does that mean for carbon? So let me circle the number. So we have 1 unpaired here, 2, 3, and 4. So that tells me carbon can form 4 bonds, and carbon is reactive. Okay, so that's a Lewis dot diagram, and that's how you explain them. So let's try another one. Let's try Na, which is sodium. So remember the first step. The first step is to look at the periodic table. And here it is. And if I find sodium, sodium is right here. Okay, so its symbol is Na, and sodium is in group 1. No, wrong thing. So if I put this right here, okay, so Na, and I'm going to put it's in group 1. So that tells me it has 1 electron in its outermost energy level. So if I, again, cheat and draw my circle right there, that's my electron dot diagram. So now the next steps, I have to find unpaired electrons. Well, this guy's all alone, unpaired. So what can it do? It can form 1 bond. And that also means because that guy doesn't have a buddy, it's reactive. And that's a Lewis dot diagram for sodium. Let's do another one. Let's do fluorine. Let's do fluorine. Fluorine is F. Now I'm going to look at the periodic table and find fluorine. And fluorine is right over here. Beautiful circle, right? And fluorine's capital F and is in group 17. So I'm going to write that information down on my workspace. So we've got F, and it's in group 17. Now remember, because it's got 2 digits, it doesn't mean it has 17 electrons in its outermost energy level. You ignore the tens place and you just use the ones place, which is that 7. So it's got 7 electrons. So I'm going to do my 7. 1 goes up top, and it goes right, and then goes down, it goes left. So right, down, left, up. That's number 5, 6, and 7. Oh, that one's kind of big. All right, so now I'm going to do the unpaired electrons, and I only have this one right here. So that means it can form 1 bond, and that it is reactive. Well, I hope this helped you guys. If you get in any sort of trouble or need some more refresher or help with it, you can come see me on a Zoom. You can text me. You could even set up a time we could call. We could talk on the phone, whatever works for you. I want this to be easy for you. Everyone out there, stay safe, have fun, and I'll see you again later.